Hi, this is Ryan Lawrence, the inventory model for the block company here. These are our blocks, our raw materials. Now our raw materials and our additional supplies are our dependent demand items that we need for our manufacturing of our blocks. Now our raw materials, there's quite a few methods of transportation available to get them to our manufacturing plant. Now there's a new manufacturing plant there. Now we prefer the rail and truck because our blocks are heavy. As you can tell by our robot workforce, our new manufacturing plant is highly automated. We've got trucking again to our distribution center. As you can tell, our distribution center is a little older there, mainly a manual workforce. This is where we keep our safety stock and any service parts for our blocks in case there's any need for that. Then we have trucking again out to the retailers, and from the block towers you can see that red is our best seller, our A inventory. Now the blue and the yellow would be our B inventory, and green our C inventory there. And you can also tell that per retailer they sell different ones at different rates as well. So we've done our analysis. Now everyone across the supply chain communicates well and cooperates. So we've been partners for quite a while. Now we've got our suppliers, our manufacturers, our distribution center, our retailers, and then the end consumers. Now, in my model there, now we do have high fixed costs for the new factory, but low labor costs because it's mostly automated. Now the inventory is very accurate. Now, across our facilities there, even the old distribution center, and even most of the retailers, we have all gotten on board. We have all installed the installed RFID systems to make everyone's life easier and keep the inventory taken care of for us, correct, and balanced and all of the above. So now for the old distribution center, now the fixed costs are low, but the labor cost is high. It's mostly manual. It's where we keep our safety stock. It's where our pallets are sorted to match the order, to match the retailer's demand. Now the retailers pull from the distribution center when a reorder point is reached there, so we avoid stock out situations and maintain high customer service there. And then the distribution center is replenished from the factory, and then the factory would get new raw materials once again. So basically it's efficient because the fact that it's a new factory there. It's been designed with our block making specifically in mind. Now it's highly efficient with space, utilization, and so forth. And it's been designed with rail shipments and trucking in mind. So, and with the high level of automation there, so to keep labor costs down. So, and everything from the new factory to the old distribution center to the retailers, everybody is efficient with our RFID there. That way everybody is keeping track of everything. That way in real time we all have the data to know when we need to reorder there. So, and then I kind of came up with this design. I mean, it's pretty basic. Just wanted it to be kind of realistic because, I mean, in the real world you're probably not. I mean, and even with the RFID, that's, you know, making it easy there. But really, probably the old distribution center, they'd probably still be back on bar scanners, or the retailers would be back on barcodes, scanning, so that kind of thing. So the real world's messy, it's not nice and pretty, so I kind of wanted to have a new factory and an old distribution center there to kind of illustrate that.